Okay, good morning everyone. Today we are revising some derivations from work, energy and power. Okay, we can start with first work done. Okay, so work done. Just I am revising the concepts once again for your final exam. Okay, work done is nothing but what? So whenever we are applying force on any body, it displaces through some distance. Okay, suppose if I have a body having mass m and the body is initially at position A. So I applied the force and the body is get displaced somewhere here. Okay, and this point is B. This displacement is nothing but what? S. Okay, or you can take it as a X. So here total work done is nothing but what? Force into displacement. That means we can take a product of force into the displacement, then only we can say that is a work done. So if there is a no displacement, then no work done. That work done is called as a zero work done. So work done we are measuring in terms of joule. That means it SI unit is nothing but what? SI unit is joule. Okay, we are denoting by letter J. Any work, okay, work is also one kind of energy, and that all energies and all work done or work we are denoting or we are measuring in terms of joules. Okay, so we have total here three types of work done. Okay, we have here three types of work done. So first work done, that is positive work done, then we have negative work done, and then we have last is zero work done. Okay, so positive work done means what? My body is moving in the direction of applied force, means F and S are in the same condition. In that case, angle value should be what? 0 degrees. Okay, means suppose here this is what a surface and this is what a object. I am applying force over here. So object is what? Going in the direction of applied force. So angle between that object and the surface is equal to 0. Both are moving in the same direction. That work done is called as a work done. Then what is a negative work done? Means applied force is in this direction and displacement is in the opposite direction. So that is called as what? Negative work done, and in this case theta is equal to how much? 180 degree. Okay, means what? I am applying force in this direction and displacement going in the opposite direction. So this forms what? A straight line angle which is of 180 degrees. Okay, so that is called as a negative work done. For example, in negative work done we can say that when we apply the brakes, okay, so car is in a motion initially or it is traveling with certain velocity, and when we apply the brake then speed is get reduced and car is what means acceleration becomes what here? Negative. So in that case the theta is nothing but how much? 180 degree. So whenever you are erasing the whatever the things you wrote with a pencil, and whenever you are erasing, in that case also there is a negative work done, and in that case also you will get the angle 180 degree. Okay, and zero work done means what? Zero work done means on the rigid wall I am applying force. Okay, on the rigid wall I am applying force, but wall is not moving. There is a no displacement. So in that case your work done is 0, and in that case theta is equal to how much? 90 degree. Applied force is there. Okay, but displacement is equal to what? 0. So here there is a no displacement, there is a no work done. So what we learn from this board, whatever the conclusion I wrote there, work done, work is done by the object is defined as what? Product of the magnitude of force into displacement, and if there is a work done by any body, that work done is given by F into S. Its SI unit is nothing but what? Joule. Okay, and here we have a three types of work done: positive work done, negative work done and zero work done. So in positive work done, force, the applied force and the motion of the body are in the same direction. In that case theta is equal to 0. Negative work done, when applied force and displacement both are exactly opposite in the direction, in that case you will get negative work done. And whenever there is a zero work done means I am applying force but object is not displacing, which is not moving. So in that case I will get work done is equal to 0. So here in this case theta is equal to 90. We are measuring the work done in terms of joule. Okay, its SI unit is nothing but what here? Joule. Can you getting up to here? Okay, people are writing the work done unit also. Joule also is one of the unit, and another unit is force we are measuring in terms of Newton, and distance we are measuring in terms of Newton meter. Both the units are correct. Okay, getting up to here. Understood up to here? So take a screenshot of this. So for any work done, there should be a displacement. This is the necessary condition for any work. If any work done you are taking, the necessary condition is that displacement. Displacement is must, then only the work can be done. Okay. So take a screenshot of this. These all are short notes. Okay. I will take little. This is this there. Okay, you can take a screenshot, then we'll go for the next part. Okay. Finished. Okay, so this is what the work done. So this is very important. We'll do the numericals once I finish the theory of this chapter. Okay, I hope everyone is getting this concept. We are just revising. That means you already read all these things. I'm just brushing up that concepts. Now next is nothing but the energy. Okay, very important part, energy. Now entire chapter is on energy only. Okay, so energy is nothing but what? A capacity of a body to do work. Okay, a capacity to do a work by the body is nothing but what? Your energy. Can you get it? Capacity to do work by the body is nothing but what? The energy. So here its unit of measurement or SI unit of energy is nothing but what? Again joule. Okay, and we have different forms of energy. So here one more thing, 1 kilojoule is nothing but, kilo means 1000. So 1000 joule we can write it. Okay, so we have different forms of energy. Okay, what are the different forms of energy? We have a solar energy, we have a potential energy, we have a kinetic energy, we have thermal energy, electrical energy, chemical energy. Okay, different. So I will write here, first one is kinetic energy, second is potential energy, third is here heat energy. Okay, then we have the chemical energy. Okay, so many different forms of energy we have. Heat energy, then chemical, then electrical energy. We have, then we have light energy. Okay, so many forms of energy we have. So, solar energy, mechanical energy, light energy. Okay, so these are the different forms of energies we have. Okay, and these are nothing but what? The for different types of energy we have, and we are using every day different types of energies. Means all these energies, kinetic energy, potential energy, heat, chemical, electrical energy, light energy, solar energy. So these all are what? Energies, and we are using in day to day. But all the energies are measured in terms of joule. Okay, so here all the energies are comes in picture when we are doing work done, or when we are doing any work. In that case only this energy arises. Okay, so here very important thing, that is nothing but total energy. Okay, total energy, or we can say that mechanical energy is nothing but kinetic energy plus potential energy. This is very important formula. Okay, so if I want to calculate the total energy of the system or total mechanical energy of the system, then you have to take a sum of potential energy and kinetic energy. Then what are these two energies? Now we have to discuss. But this is what the basic of the energies. Okay, energy is nothing but what? Capacity of doing work, or any body is doing some work in a given interval of a time, that is nothing but energy. Energy is measured in terms of joule, and here 1 kilojoule is nothing but 1000 joule. And we have different forms of energy: kinetic energy, potential energy, chemical, electrical, light energy. Okay, and here if we want to calculate the total energy or mechanical energy of any system, then we are taking a sum of potential energy plus kinetic energy. Getting this? Take a screenshot. These are all short notes for this chapter. It's very easy to remember. Take a screenshot of this. Everyone is getting this? Okay. So now we are discussing kinetic energy and potential energy in detail. Okay, because we have a derivation for kinetic energy, potential energy, we have number of numericals on both the energies. So this is a basic for energy. I already explained this. Now we will go for kinetic energy, derivation of a kinetic energy, potential energy and derivation for potential energy. Okay, then only we can go for various numericals based on this. So I hope everyone understood the energy. Now next heading is nothing but your kinetic energy. So what do you mean by kinetic energy? Kinetic energy is possessed by any body. That means that body is in a motion. Very important thing. Whenever body is in a motion, that body always possesses the kinetic energy, and always remember kinetic energy increases with increase in the velocity. So more is the velocity, more is the kinetic energy. Less is the velocity, then less is the kinetic energy. Okay, but here thing is that kinetic energy means body should be what? In motion. If that body is in a motion, then only it possesses what? The kinetic energy. Understood? Now we have to go for the derivation. Okay, so how to derive? Okay, I know, I by hearted. I know the formula. Even students know the formula for kinetic energy, half mv square. This is what the formula for kinetic energy. Okay, but this year we have to prove kinetic energy half mv square. How will it come? Okay, so body is in a motion. That means the body is performing some work done, and that work done is nothing but what? Force into displacement. Just now we did. What do you mean by work done? Work done is nothing but force into displacement. F into S. Getting up to here. Okay. Now that body is in the motion. Okay. Then we can use the kinematical equations or kinematics equation. So initial velocity of the body is u. Final velocity of a body is v. And S is the displacement and A is the acceleration of that body. So we can use this equation, v square is equal to u square plus twice as. Okay, so we can go for this equation. So from this, what we can calculate? So from this we can calculate the distance s. Okay, so you can send this u square here. So v square minus u square equal to twice of as. Now again v square minus u square to a. Okay, a is nothing to a is equal to s. This is what s I got. Understood? Okay. Now if the body is in the motion, that means that body possesses some acceleration also. And according to the laws of motion, f is nothing but what? Mass into acceleration. This is my equation number 1 and this is my equation number 2. And you can take this as a Roman numeral 1. So now what you can do? Put 1 and 2 in equation number 1. Okay. So now here put equation 1 and 2 in what? In Roman numeral 1. So work done is nothing but, force is nothing but how much? M into A. And what is this? S is nothing but, we have a v square minus u square divided by 2a. So this a and this a get cancelled because there is a multiplication. Okay. So what will remain here? M v square minus u square divided by 2. Suppose body initially at a rest. Okay. That means u should be how much here? 0. So work done is nothing but m v square divided by 2. Can you get it? So work done is nothing but what? Kinetic energy, and that kinetic energy is nothing but mv square by 2. or half mv square. So how we derived it? Now this is what hence proved. Hence proved, very IMP derivation from the exam point of view. Okay, so you can learn this derivation properly, because again in 11th standard you have the same chapter, same derivation we have to do. So kinetic energy is nothing but what? Any body is in a motion, it possesses the kinetic energy. If v means speed increases, velocity increases, then kinetic energy is also increases. Kinetic energy is also measured in terms of joule. We know the formula half mv square, but now here we have to derive. So how to derive? Here I am saying body is in a motion, that means it performs some work done, and that work done is nothing but how much? Force into displacement. And here we are using kinematics equation, because body is initially at a rest. Now it is traveling with velocity v, and it shows some certain acceleration, and it covers covers some distance, and that distance is nothing but what? S. There is no displacement, then no work done, energy is equal to what? 0. Okay, so here I rearrange the terms, I transpose u over here. So v square minus u square twice s, and I obtain the value for s. So s is nothing but v square minus u square upon 2a, and f is equal to ma. Understood? So this is my both equations I got. Take this equation and keep it into the first Roman numeral. So w is equal to, f value is nothing but m into a, and s is nothing but here I have v square minus u square by 2a. I substituted acceleration get cancelled. So initial velocity you can take it as a 0, and then you get w is equal to m v square by 2. So m is nothing but mass of the body, and kinetic energy is equal to half mv square, which is proved here. This is what the derivation for kinetic energy. Getting this derivation, take a screenshot. You can take the screenshot of this. Getting all of you how I am deriving. These are the very simple and easy steps. Copy this, or you can take a screenshot. Okay, took everyone's screenshot. Now we will go for potential energy. Okay, potential energy is very easy. Okay, we can derive in 2 steps only. Okay, so I hope everyone understood the kinetic energy. So, and its derivation. I tried my level best to explain this derivation, and this derivation is very important from the exam point of view. 100% there is a chances to ask this derivation in exam. Okay, now we will go for potential energy. Potential energy means whenever we are taking any body and we are raised to certain height and we kept it over there, that means that object is showing maximum potential energy. Suppose here this is a ground level, and here body is having mass m. Okay, and this is what one tall building is there. Okay, this is what height of this building, h. Okay, so I took this mass and I kept this mass at the top of the building. Okay, I took this mass, a block of mass, and I kept at the certain height h. Okay, so whenever we are taking this mass and we are keeping our certain height, then its weight component is also acting vertically downward, that is nothing but m into g. Its weight is what? Acting vertically when you are raising to certain height h. So here potential energy is nothing but what? Work done. Work done is nothing but here force into displacement. I know work done is nothing but force into displacement s. So force is nothing but what? F is equal to mg is also the component of the force, because it's because of the gravity. The gravitational force is what? Pulling this mass towards it. So F is equal to what? Mg, and distance is what? Displaced by h. So W is nothing but mgh, and this work done is also one form of potential energy. Okay, so work done is potential energy is nothing but what? Mgh, and this potential energy is also measured in terms of joule. Can you getting this? Understood this? Okay, it's very easy than the kinetic energy. Okay, and very important thing here, potential energy, or here whatever the displacement takes place, work done takes place, that is a path independent. Path independent. Okay, suppose I am taking this body somewhere here, then I took it and I kept it. Doesn't matter. Doesn't matter what path, what road it follows, but it raised to certain height. That is nothing but what? The potential energy. Okay, means I want to reach from my home to school. Number of ways are there. You can choose any one, but your work done or your potential energy will remain same. It is a path independent. Understood? This statement is very important. Maybe they will ask this for MCQ. This is also measured in terms of energy. Getting this? Understood? Take the screenshot of this. Take a screenshot of this. Okay. Once we done, then here suppose initially body is moving with certain velocity, and it comes to some final velocity, then in that case we can write, that is work energy theorem, that is according to work energy theorem, we can say that kinetic energy is nothing but half, we can write m v square minus u square. This is kinetic energy net. Okay, this also one formula, you can note it down. Okay, then this is one statement, this is what the one of the formula, you can take the screenshot of this. Then we can discuss about the law of conservation of energy. So everyone know law of conservation of energy. So already this statement 100% this statement will come for at least 1 mark. So what is the conservation of energy? Law of conservation of energy. This law states that the energy neither be created and nor be destroyed. Okay, but we can convert into one form to another form. This is what the statement of law of conservation of energy. Okay, I will repeat one more time. This law states that energy neither be created nor be destroyed, but we can convert from one to another form. Okay, and hence here we can say that energy in the universe will remain constant. Okay, understood up to here? Okay, so can we go for power? So once I'll finish the power, then we can go for the numericals from this chapter. Okay, we can cover numericals. Already I share one PDF, so according to that we are doing the numericals. Okay, so here apart from that, if I have a time, then I can cover some extra questions too. So now give the heading power. Give the heading power. I hope everyone took the screenshot of potential energy. Okay, there will be one more session today in the afternoon about another chapter of class 9. Okay, power. Give the heading power. Power is nothing but what? Rate of doing work. Rate of doing work is nothing but what? Work done. Power is nothing but what? Here we can write power is nothing but work done by time. Okay, so its unit is joule per second, or power is measured in terms of watt. Okay, and we can write this as a W or watt. Okay, SI unit of power is nothing but watt. Okay, and here power 1 kilowatt is equal to, we can write 1 kilowatt is nothing but what, 1000 watt. Okay, and 1 kilowatt is also how much, we can write 1000 joule per second. This is also correct statement. Okay, and what is the commercial unit of energy? This is also very important. They will ask one more question on this, commercial unit of energy. What is the commercial unit of energy? 1 kilowatt hour is nothing but 1 kilowatt into 1 hour. So 1 kilowatt is nothing but 1000 watt into 1 hour is nothing but how much? 60 into 60, that is 3600. So I will write 36 into 1 2 3 4 5, 10 raised to 5 watt. Okay, is the answer. Getting this? Or we can write 36 into 10 raised to 5 joule, or we can write here 3.6 into 10 raised to 6 joule. Okay, so we can write this commercial unit, and always remember 1 kilowatt is nothing but what, 1 unit of the given supply. Okay, these are the this is what the power and basics of the power. Here the thing is that important is that power is equal to work done by time. Okay, you should know what is its SI unit, that is watt. We can measure it in terms of watt, and it's also denoted as, means SI unit is joule per second, and we can write 1 kilowatt is equal to 1000 watt or 1000 joule per second, and 1 kilowatt hour is nothing but, why, you can split it. Okay, 1 kilo is nothing but 1000, hour means 1 hour 3600. Okay, so 36 into 10 raised to 5 joule, or 3.6 into 10 raised to 6 joule. So this is nothing but power. I hope everyone understood the theory for this chapter. I almost cover the theory which you have in class 9. Okay, getting this? Understood? Yes, everyone is getting? Okay, write down. Now we can go for some worksheet questions. I already shared in my group. Here they first gave the MCQ. When body falls freely under the gravity, then the work done by the gravity is. Dekho, I will repeat the question. When a body falls freely under the gravity, then the work done by the gravity is positive, negative, 0, infinity. Okay, the body is what, freely falling under the gravity, so that is nothing but what, the work done by that that is nothing but the work done by the body is nothing but positive. Okay, so option A is here correct option. Okay, I will repeat the question. When a body falls freely under the gravity, then work done by the gravity is nothing but what, positive. Can you getting this? Okay, next question. For a body moving in a motion. Okay, here body is moving in the motion. The work done is equal to what? Okay, they gave the option kinetic energy, potential energy, heat energy and chemical energy. So body is in the motion, that means it possesses the kinetic energy. Just now I told you the definition for kinetic energy. So here answer is what, kinetic energy. Body is in the motion means it possesses the kinetic energy. Okay, option A is the correct option. Now next one, what is the unit of energy? And options are given: joule, Newton, Newton second and kilogram. Okay, what is the unit of energy? Energy is always measured in terms of joule. Okay, energy is always measured in terms of joule. So here correct option is nothing but A. Getting this? So next question is based on some MCQ, based on a numerical. They are saying here a person is holding a bucket. Okay, by applying a force of 10 Newton. So I will try to show this with a diagram. Okay. I don't know, I am not good at drawing, but I will try to draw a stick man. Okay, so here one person is there and he holds the bucket. Okay, he holds the bucket is like this. Okay, so there is what? A force applying is 10 Newton and climbs up a vertical distance of 10 meter. Means suppose here somewhere here one mountain is there. Okay, and he started walking here and he reached here. That person now reached here with that bucket. He reached here with the bucket. So this cliff is nothing but how much? 10 meter in height. Okay, and here how much is the force is nothing but what here? 10 Newton. So that weight is acting vertically downward and he reached to certain height. This is the concept or question based on potential energy. Initially he is at ground and that person is raised up to certain height 10 meter. So here potential energy is nothing but what? mg into h. So m is nothing but mg is nothing but 10 Newton, no, because this is acting vertically downward. That means this is mg component only. So mg is nothing but 10. Height is also 10. So answer is what? 100 joule. Getting this? So like this we have to solve the problem. So here options are also given: 50 joule, 150 joule, 100 joule and 200 joule. So answer is C, that is 100 joule. Getting these questions? How to solve? You can just imagine, okay, and then you can try to solve. Apply the concept. Concept application is very important in physics. Okay. Getting up to here, everyone? Does anyone is having problem? If you have any queries, you can just message me or type the message. Type the message. Okay, now next one is that the energy possessed by the body in a motion is called kinetic energy, potential energy, motional energy, and none of this. Again same question repeated. Energy possessed by the body in a motion, that is kinetic energy. Okay. So now next question. So they are asking second 2 marks question. Define kinetic energy and potential energy. So kinetic energy is nothing but what? The body which is motion, that means it possessing kinetic energy. If speed is more, then kinetic energy is also more. What do you mean by potential energy? Potential energy is nothing but what? A body is raised or work is done through some distance, or body is get displaced through some distance, then only we can say that in that case that body possesses the maximum energy. That energy is known as potential energy. Getting this? And give one example. Okay, now then they are saying what are the 2 types of mechanical energy. So we did different forms of energy, and mechanical energy is nothing but total energy. So you can take an example of electricity. Then when we turn on the electricity, that is gets converted into mechanical one. Okay, so many examples we just discussed. You can write any one, any 2 of them. Okay, so now they are asking write the formula for to find the work, and work is a scalar or vector quantity they are asking. Okay, so what is the work? Work is a scalar or vector quantity? Yes, anyone can type. Someone can type whether work done is a scalar or vector quantity. Yes, does anyone know? I don't know. Tell me. Yes, anyone knows work done is a scalar or vector quantity? Work done is nothing but what? Scalar quantity, no? And they are saying write the formula for work. Work is nothing but what? Force into displacement, or F into S. Okay, force, and this is the displacement, but we don't know the direction here. We know only magnitude. Magnitude means we know only value. That's what work done is nothing but what? A scalar quantity. Okay, it gives only magnitude, not by that, not direction. So that's what it is, a scalar quantity. Getting this? Next question they are asking 1 joule. Define 1 joule. Okay, they are asking work done is nothing but 1 joule or any energy is equal to 1 joule. So I will explain this force into displacement. This work done is also one form of energy only. Okay, whenever we are providing 1 Newton of force and the body is get displaced by the 1 meter. So in that case work done is nothing but 1 into 1 is nothing but 1 joule. Okay, so you have to write the definition. 1 joule is the work when we are applying 1 Newton of force and body is get displaces by 1 meter. So resultant work done is nothing but 1 joule, and this you have to show it, this procedure in the exam. Getting this? Understood? Okay, then write down one question. Derive the expression for kinetic energy. Next question, derive the expression for kinetic energy. Now this I will not solve. Okay, this is already I did at the beginning of this session. I derived the formula for kinetic energy. Now next is derive the expression for potential energy. Okay, that also derivation we did. That is P is equal to mgh, and kinetic energy we did it as a half mv square. That also we did. Okay, so now that two questions are already over. Now next question is that a body of mass 5 kg. Okay, they are asking here a body of mass 5 kg is moving with velocity 10 meter per second. What is its kinetic energy? Very important. We will explain this how to solve. See, so what are the given quantities and what they are asking is very important, and we can apply which formula according to the given conditions are very important. Here they are saying, here the question is that a body of mass 5 kg, means mass is given 5 kg. Okay, and the body is moving with velocity v is equal to how much? 10 meter per second. So what is its kinetic energy? So kinetic energy they are asking. Okay, always remember if the values are given in centimeter to second, then convert it into meter. Okay, gram is given, then you can convert it into kg and then solve. Here the values are given in the standard form, so here we can write the formula. Okay, kinetic energy is nothing but half mv square. Always remember you have to write the formula first. For writing correct formula you will get half mark, for substitution you will get another half mark. Okay, don't lose these marks. Okay, we are not at all writing the formula directly, we are substituting the value, which is wrong. Okay, so here we can write half, mass is nothing but 5 and v is nothing but 10 ka square. So here 5 into 10 square is 100 by 2. So this is nothing but 50. 50 into 5, that is nothing but 250 joule is the kinetic energy. Getting this? समझ में आ रहा है सबको? Understood how to solve this? Okay. Take a screenshot and we'll go for the next question. Next question, I will dictate. Find the potential energy. Find the potential energy possessed by a body of mass, 2 kg, kept at a height 50 meter, and g they are asking us to take 10 meter per second square. They are asking potential energy. Potential energy is nothing but what? Potential energy is nothing but mgh. So here mass is given how much? Potential energy, no, mass is given 2. G they are asking us to take 10, and height they are saying 50. Okay, so 10, this is nothing but 20 into 50, 10 and these two zeros, that is 1000 joule. Okay, this is nothing but what your potential energy. Okay, I hope everyone is getting these questions. Now write down the next yeah. So there is a case-based questions are given. Okay, I will read that case-based question. Work done in science is much different from the conception of work in our daily life. We consider that work is being done by a clerk while sitting at one place from morning to evening. Okay, and they gave first question, a coolie holding luggage of 10 Newton for 10 minutes. Okay, what is its work done? देखो हाँ, very important question. Students are calculating mgh. Okay, but this is whether correct or not, you have to think it. So they are asking a coolie holding a luggage of 10 Newton for 10 minutes, what is its work done? Okay, so what is its work done? See, that coolie took that weight and he kept it on his head. Okay, but there is a no movement. He raised to certain height. Okay, but there is what maximum. They are saying here, yeah, 10 Newton for a 10 minutes. If he is holding for 1 hour also, that does not matter. There is a total work done by the body is equal to 0 only. Okay, read the questions carefully. A coolie holding a luggage of 10 Newton for 10 minutes. People are thinking 10 minutes, but height is not given. No, height is not given. That is also an important thing. Okay, and he just holding and kept on his head. That's it. Okay, so here the work done by the coolie on that weight is equal to 0. Understanding, getting this, how to solve this kind of logical questions which are given in the case based question. If you are clear with the concept, then only you can able to write the answers. Okay, now next, a body is moving along the straight road. What type of energy the body possessing? Okay, if it is going straight or it is going curved, that doesn't matter. That body is in the motion is very important. This body is possessing the some velocity. It is traveling with certain velocity. That means it is in the kinetic motion. This is the answer. Now next one. A pair of bullock exerts a force of 10 Newton on the plough. The field being ploughed in 15 meter long in 15 seconds. How much is the work done and the power developed? Okay, so how can you calculate here? Dekho, I will write down. This is what the calculations are here. Okay, here pair of bullocks are there. The total force is nothing but 10 Newton. Force is nothing but 10 Newton. And the field is being ploughed for distance. The distance is given. Okay, distance is given 15 meter. Correct. And the time is given in 15 seconds. They are asking here how much is the work done and power developed. Work done is easy, no? Force into displacement. Force is 10, displacement is 15, that is 150 joule is the work done over here, and power is nothing but what? Work done by time. So work done is here 150 and time is 15. So 10 watt of the work, 10 watt of power is what consumed over here. Can you getting this? Understood? Is everyone is getting what I am explaining? Okay, now there is one reason and assertion is given. Assertion is given, a force of 10 Newton is acting on the rigid wall. Okay, the work done is 0. Yes, true, because wall is not displacing. At the beginning of this session, I made the table. 3 categories of work done I explained. So when the 0 work done, if there is a no displacement, no work done. So assertion is true. Work is done if the bodies get displaced due to force. Yes. A is true, R is true, and R is the correct explanation over here. Getting this? Now, next assertion is given, work done by the force of friction is negative. Yes, friction, yes, that is negative, and frictional forces always acts in the direction to that of motion of the body. Yes, true. Motion of the body means it is applied. Friction is always opposite in the direction of applied force. Getting this? So yes, the frictional force, that A and R are true and R is the correct explanation. Okay, can you getting this? So few questions I covered, means the entire PDF which I told you to prepare, that we finished. Now we can go for some other questions for work power energy. Just give me time. I will take some questions. Uh, I will give you some other questions too from the same chapter. Okay. Okay. Chalo. Write down next question. Write down next question. If 1 Newton of force is if 1 Newton of force displaces a body of 1 meter, the work done is first option 10 joule, 5 joule, 1 joule. 10 joule, 5 joule, 1 joule, and depends on the time. Okay. So here the question option will come here 1 joule, no, because body there is a force of 1 Newton, no. So I am applying force F is equal to 1 Newton and displacement is also 1 meter. So total work done is nothing but force into S, that is 1 into 1 is equal to what? 1 joule. So option C is the correct option. Okay, write down this. Now write down next one. On tripling the speed, TRIPLING, on tripling the speed of motion of a body, on tripling the speed of motion of a body, comma, the change in kinetic energy is, okay, first option 9 times, 8 times, 4 times and 2 times. I will repeat this question. On tripling the speed of a motion of a body, the change in kinetic energy is 9 times, 8 times, 4 times and 2 times. Okay. So here there is a change in kinetic energy. Means speed is what you are changing. And they are asking the question about the kinetic energy and they are saying they are increasing its speed by 3. Tripling means 3. Okay, so any body initially it is possessing, so kinetic energy I means initial, half mv square. Okay, now they are tripling, means v is nothing but what? 3. They are tripling the speed. Okay, so v is equal to 3. Then kinetic energy final half m, here 3 times of v square. Okay, so half m 9 into v square. Okay, so here I will write 9 aside. I will write 9 over here and remaining half mv square. This is nothing but what? My initial kinetic energy, no? So 9 into kinetic energy initial. So we can conclude here the final kinetic energy is what? 9 times of the initial kinetic energy. Suppose they are asking for doubling, then this will becomes 4 because we are squaring that speed. Okay, getting this, how to solve this kind of question? Maybe this question comes for 2 marks also. Okay, here they are asking for 1 mark, but maybe they will ask this question for 2 marks. Okay, getting this, how to solve whenever this kind of questions will come. Okay, so take a screenshot of this, then write down next question. A mass is moving, write down next question. A mass is moving 5 meter per second. A mass is moving 5 meter per second with speed of along the x direction on smooth surface, comma, when a force of 5 Newton acts on it a force of 5 Newton acts on it when a force of 5 Newton acts on it along the y-axis, full stop, the work done by the force is 25 joule, option is given 25 joule, 10 joule, depends on the time, and last is 0. Last option is 0. I will repeat one more time. A mass is moving 5 meter per second when speed of along x direction on the smooth surface, when a force of 5 Newton acts on it along the y-axis, full stop, the work done by the force is 25 joule, 25 joule, 10 joule, depends on the time, and last option is 0. Okay, which one will come correct? Does anyone can explain this? Yes? Can anyone? Here the mass is moving with 5 meter per second with speed along the x direction on the smooth surface when 5 Newton acts along the y-axis. Okay, what is the work done? Work done kitna hoga re? It's a logical question. Here no need of calculation. I think people are started calculating what is the work done. So here there is the question. Okay, body is in here where on the x-axis. I will draw here the coordinate system. This is what x-axis, this is y-axis, and what they are saying here, the mass is there with speed 5 meter per second. This body is here along the x-axis, it is traveling with 5 meter per second. Okay, and when force is at 5 Newton in the y direction, देखो force जो है that is acting along the y direction on this, but movement is in the x direction. So here resultant work done is equal to what? 0. Okay, so no need of calculation, use brain, logic apply and calculate. Answer is here D, that is a 0 work done. Understood? Okay, write down next question. An electric bulb of 60 watt burns for 5 hours in a day burns for 5 hours in a day, full stop. The cost of electricity involved, the cost of electricity involved in a month of 30 days, in a month of 30 days at rupees 3, at rupees 3 per unit, per unit is first option 270, second option 27, third option 2.770, 2.70, 2.70, last option 2700, 2700. Okay, calculate this, check what is the answer. If you want, I will repeat this. I will repeat this question. Here, a electric bulb of 60 watt burns for 5 hours in a day. A cost of electricity involved in a month of 30 days at rupees 3 per unit is 270, B 27, C 2.70, D is 2700. Okay, so just now I told you commercial unit, okay, of the power is always in kilowatt hour. So how to solve this? Here, see, here power they gave it as 60 watt. Power is given 60 watt. So power is nothing but convert it into kilowatt. Okay. So 60 divided by 1000 kilowatt. So here this 0 and this 0 get cancelled. 0.06 is nothing but what your kilowatt. Okay. And once you will get this power, then they are saying what here 5 hours a day and 30 days and 3 unit. So here total cost is equal to multiply this power into number of days, number of hours which we are consuming and cost is how much they are saying 3 rupees, no 3 rupees. Okay, do this, check the calculation with me. ₹27. Here the per unit, the cost of electricity involved is nothing but what 27. Option is here B. Getting this? So power is given in terms of watt, then converted into kilowatt. Okay, this is what understood. So next question give oral. Okay, check the answer. When a body falls freely towards the earth, then total energy increases, decreases, remains constant, or D, first increases and then decreases. Okay, so I will repeat here, increases, decreases, remains constant, first increases and then decreases. A freely falling body towards the earth, freely falling body towards the earth, the total energy will remains constant. Okay, only they are asking total energy, not potential kinetic energy. Total energy of the system will remains constant because we have to use the law of conservation of energy, because energy cannot be neither be created nor be destroyed, but we can convert from one form to another form, and universal energy everywhere will remains constant. Understood? Then chalo, next question, write down. A force of F Newton moves. A force of F Newton moves a body with constant speed V. A force of F Newton moves a body with a constant speed V, the power delivered by it, is first option F by V, second F into V, C F square into V, F square into V, F square into V, and D last option V by F. Okay, so they are asking here if the force of F Newton moves a body with a constant speed V, the power delivered by it is what? They are given option F by V, FV, F square V and V by F. Okay, can you calculate the answer for this? How to calculate? They are asking here the power delivered. Power delivered is nothing but what? They are asking power. P is nothing but what? Work done by time, and they are saying work done. Work done is nothing but one kind of, we can say that here they are saying speed also, no? Force F and constant speed V. Okay. Here work done is nothing but force into displacement D or S divided by time. Okay, then force F is equal to, I will write T. Distance is nothing but what? Speed into time, no? Distance is nothing but speed into time. So speed, distance into speed. Speed is nothing but V here. So V into T I will write. So T get cancelled and I will get the answer FV. So how the formulas I am using, how we can flip the formulas and how we can do the substitution for distance S or displacement X or S. Okay, distance is nothing but speed into time. You know, you have to remember all these things and apply. Then only you will get the proper answers over here. Understood? Okay, write down. This you can give the answer orally. Which one of the following is not a unit of energy? देखो, which one of the following is not a unit of energy? Joule, kilowatt, Newton meter and kilowatt hour. What will come? Here, which is not a unit of energy? Joule, Newton meter, kilowatt hour and kilowatt. Here answer is kilowatt. No, kilowatt is a power of unit, a unit of power. Correct? So here answer is what? Kilowatt. Okay. Now this also you can give. When a coil spring is compressed, the work is done in the spring. The potential energy increases, decreases, remains constant, increases and then decreases. Okay, so what will happen when you compress the spring? So whenever we are compressing the spring, suppose this is, we have a rigid body and I compress the spring and I hold it like this. So you compress and keep it, that means it shows a maximum potential energy, and that is potential energy is what? Increased over here. Okay, the option will come here, increases. Okay, now next question, the number of joules contained in 1 kilowatt hour. The number of joules contained in 1 kilowatt hour. Just now I gave the commercial unit, that is 36 into 10 raised to 5 is the answer. That is in terms of joule. Okay, so that I already did and I covered almost the number of MCQ which are present in it. Okay, so check once. Okay, so here okay, so okay, next instructions I will give it into the group. You can just check once, and I covered almost all the questions. In the afternoon, if I am taking the tuition, I will inform you. Okay, so I will send it to you. If I am taking, then I will send you the link. Okay, thank you. I will end this session now.